So before I start on CAD, a note in the chat, somewhere between joking and serious, who needs Git when there's OneDrive? Just to recap that point. Dropbox, OneDrive, Google Drive, all let you manage content. The reason we're not using them, one is those all are central companies hosting your content, and you can have files locally, but it's with respect to a central server. Git lets you own your content and host it wherever you want to host it, is one difference. And then the other important one is those have a notion of history, but they don't have the powerful tools of branching and merging that we've been using for project management. And so I make use of those tools for things that fit them, but they don't replace owning your own data and having the powerful collaborative management tools in Git, which is why we use Git. So here we go. Today's class is CAD. It's going to be a software class. And then next week, we get in the labs and start cutting things. No recitation this week. That'll pick up next week. Each week in the assignment, I link a featured assignment. And read the assignments carefully. Every word is important. So the assignment is you're going to model a possible final project. You'll compress the images and videos and post a description, including the design files. And then I link featured assignments. And the featured assignment here comes from Nadia, who I'd say was the best documenter we ever had in Fab Academy. And what I want you to do is, the final project can evolve, but pick one. But I want you to represent it as many ways as possible. So if we go through her page, here's she made an interactive puzzle. Here's an animation of it. Here's a rendering of it. And then she drew a sketch. She made 2D drawings of it, raster drawings, vector drawings, constrained drawings. Your eyes will kind of glaze over as I scroll. Let's see there. She's using testing now, comparing a variety of different CAD tools for it. I'm going to talk about all of these. This goes above and beyond what you need to do within each week, but she tried essentially every tool I'm about to talk about and came up with all of these representations of her final project. So that's what I want you to do this week. And the goal of that is to meet the tools and find which ones you like. So we'll start with 2D design, then we'll go to 3D design, and then I'll talk about media beyond that. So, and let me jump ahead to in the cutting assignment where we cover laser cutters and vinyl cutters. You're going to make a press fit construction kit. So here's an example of a press fit construction kit. The press fit construction kit has to be parametric, meaning if you change the thickness of the cardboard, your whole design adapts around it. So just keep that in the background. A week from now, you're going to have to do parametric CAD, which I'll explain now. There's a question about licenses. I'm going to come to license. Actually, I'll come to licenses as I get to the software I'm talking about. So to start, this was an electronics assignment for fun. You can draw by hand, ink on paper, scan it in, and you can produce it on the machines. That works, but there's no real design tools. But for really expressive things, we'll cover how to scan and fabricate. Then GIMP is freely available open source image manipulation. So images are little rectangles that are pixels. GIMP is freely available open source and very powerful. BIMP is built on GIMP, and BIMP is designed to do batch operations. So you can use GIMP to resize, compress, crop. If you need to do that, a lot of images, BIMP lets you do that. And so here I am in GIMP. I'm going to start an image. I'm going to make some shapes. I'll fill them with paint. So I made a cutout just by pouring paint into a shape. And then if I scroll in, you'll eventually see it's made up of little squares of intensity. So Photoshop is a commercial tool for image editing. I spend a lot of time in GIMP for open source cross-platform. And then I strongly recommend this or a variant. ImageMagick is freely available open source. And what it does is convert any image to anything. So convert is a tool from ImageMagick. And so this can, for example, convert JPEGs to PNGs. It can do it for a directory. You can specify the resolution. A key parameter is quality. I'll demo quality settings next week. You can set the quality. And so with this tool, you can just type a little command line, take all of your images in, compress them, change the resolution. And so in your toolbox, you should have these to do batch image processing. And then you need a good image navigator. This is the one I tend to use to browse your images. And sometimes this is an interesting tool I use. This is, let's see, they don't have a gallery, but this is a tool, again, freely available cross-platform that emulates paper, paint, ink that lets you draw using tablets if you have them or a stylus and emulate various sorts of media for painting and sketching. So all of that, let's see, let me make a note. All of that is pixels. So then we need vectors are where instead of dots, you have lines. So this tool you see me use periodically is Sketchpad. To go from images to vectors, this is a tool to trace, and you can use mods that I wrote. This lets you bring in an image and then trace the boundaries and turn it into vectors. And so, for example, for a if you want to cut it out on a milling machine or a laser cutter, you need to turn it into a path. So mods knows how to do it. And then Inkscape is freely available cross-platform and is for vector editing. So now I'm in Inkscape, and I'll do something similar to what I did before, but it'll be crucially different. So I might make some shapes. Now what I'm going to do is called a Boolean. A Boolean is logic on objects. So you can add, subtract, intersect. So what I'm going to do next is I'm going to subtract an object from an object. In GIMP, I just did that visually by pouring paint on it. Here, it actually took a bite out of it. I subtracted a part from a part. The difference now is these aren't pixels. These are actually boundaries. So at any resolution, it looks the same. Then I'm going to do a borderline CAD thing. So I just did an alignment. I centered that part. Then I'm going to clone the part. I could copy it, but a clone stays connected. So now I'm going to change the color. Now, because it's cloned, if I change one of them, the other one moves. And so that's a minimal way to be parametric. Think about the slots in the cardboard. So Inkscape is, yeah, there's a question about can students use, yeah, any tool is fair game. I'm giving suggestions of tools. You're welcome to use any tool. So I make a lot of use of Ink for Inkscape for 2D vector editing. And Adobe Illustrator is a commercial tool. Then all of these are, there's a growing lineup of these vector tools in a browser. But I'm going to go right to FreeCAD. So let's see. FreeCAD, probably the worst part of FreeCAD is the name. It sounds kind of trivial. It's significantly matured as a freely available cross-platform open source modeling tool. And you can use it in 2D as well as 3D. So let me show you in 2D. So this is going to introduce one of the most important concepts for today, which is constraints. So here I am in FreeCAD, and I'll talk more about FreeCAD in a minute for 3D. It has workbenches. So I'm going to pick a workbench for sketching, and sketching is the 2D drawing workbench. So I'm going to start a sketch. And so this looks a bit like Inkscape, like or Illustrator, but it's fundamentally very different. So I'll make a shape. I'll make those boxes like I did before. Now I'm picking a tool to trim. So I'm going to trim the intersections to remove what I don't want. Now, if I move that, I can just move it. But now the key thing I can do is all of these icons are constraints. So I'm going to pick those two segments and I'm going to make an equality constraint. So that means those have to be the same size. I'll do an equality constraint there. So they stay the same size. I'll do one there. And so now I'm automatically centered. Then I'll pick a dimension constraint. I'll give that one a size. And if I set that size, everything adjusts around it. And so there's constraints to be parallel, perpendicular, fix an angle, tangent, aligned, distributed. And so typically, not always, but typically in CAD, we start by using one of these sketching tools to define our part with constraints. And then we progress through the stages. And I'll show you this in a minute of going from building into from 2D to 3D. So the key distinction, we went from raster to vector, and then from vector, we went to constrained drawing. And so if you go back to our cardboard parts, you have a single part, a single parameter, the cardboard thickness, and we want that to propagate through our design. And so for that, you need a constrained editor. So that's 2D. 3D is a much bigger world. So this is a link to a Bible of computer graphics, if you're interested in much more. This is a link to a thesis from one of my students that talks about the math at the heart of it. And if you use a Formlabs printer, he developed the supports for Formlabs, and he also did the controls for the laser scanning. 3D is much more complex. So one of the things you need in a 3D tool is when you design a jumbo jet, there's a very complex history of the design process. This is a little bit like Git versioning. So in Inkscape, all you have is what you see. One of the things a CAD tool, a more powerful CAD tool, has to do is maintain the history. So you know all the steps that got you to the present. So you can go back, and if you made a mistake or your needs change, you can change something in the history. And it's much more than an undo. You can change something in the history and propagate it through to the presence. There's chat about licenses. I'll talk about licenses in a little bit. A second thing you need to do is manage. There might be multiple people working on a project, and there might be multiple subsystems. And again, a bit like Git merging, you need to control how you all collaborate. Another thing is how you represent it. So here's an object. A boundary representation, which is historically what was used in CAD, mathematically represents the surface of the object. That can lead to problems when you make complex geometries. You can get errors. The design tools can crash. They can struggle when it gets complex. A function representation wasn't used originally because it needs more powerful computing. But instead of representing the surface, you actually represent mathematically the interior. And I'll show you that. That's more powerful, but not as common. And then what's actually growing in importance, surprisingly, is something backwards to what I'm saying, which is a volume representation is essentially pixels in 3D where you represent volume elements. And that's needed for really messy, complex things. If you want to like simulate a sand pile or waves breaking, rather than modeling the surface or the volume of every droplet, increasingly that's done using volume elements. And so we'll see examples of each of those. As your designs get complex, it's hard to do it with a mouse. And so these let you use 3D rather than 2D input devices. Marcus, yeah, a CT scan is a volume representation. Then, and I'm going to show you examples of these. When you start, you click and drag with a graphical interface. But when you want to make a more complex design, it can be a lot of clicking and dragging. And so you write scripts to automate operation. And eventually, for really complex geometries, it's hard to do with scripting, and you use full hardware description languages, which are programs for geometry. Then imperative design is where you say what you want. You click and drag. Declarative design is where you say what you want it to do, but not how to do it. And so generative design has many meanings, but in this context, it refers to the notion of like you describe you on a table, and it has to figure out where the supports are to give you the shape, and it can be more mass efficient and more organic. So like Autodesk has done a lot of work on generative design, and you get these really funny looking shapes like these, where it figures out how to handle the constraints in your design rather than you. Multidisciplinary optimization is if you're designing an airplane, there's the structural forces, there's the aerodynamic forces, there's the thermodynamics, and you need to optimize over many different kinds of physics. And increasingly, AI is growing, and I'll talk about this at the end, in its role in design tools. So all of these go into 3D design. That's why there's no one best tool. There's no one straightforward workflow. So the first thing is sketching. So many times in class, you'll see me, this is a tablet I have handy, and in class, you'll see me making sketches. When I'm doing CAD, typically I have a tablet handy, and I'm just sketching as I'm thinking through what the design is. SketchUp and Tinkercad are really easy to use, friendly tools. They're fun for beginners. I don't really recommend them just because there's a real serious limitation in complexity in what you can do with them. Blender is an interesting story. Blender in the Netherlands started as a computer graphics house. It grew into a startup with a lot of startup funding. The startup didn't succeed. They bought out their funders. It became an open source program. Its heart and soul is in rendering and animating. So it doesn't have built in a strong geometry engine, but more recently, Blender has developed geometry nodes, and Blender geometry nodes lets you make graphs of the construction of a design, which is a very powerful representation. And there's a CAD, there's the beginnings of a CAD sketching tool for Blender. So one of the things Blender is great at is sculpting. So here I'm in Blender. It has a few representations, but the most natural representation in Blender is a mesh, which is good for computer graphics, traditional computer graphics. It has a lot of limitations for fabrication, just because it discretizes the geometry in little triangles. But what I'm going to do is I'm going to subdivide the mesh, and now I'm in a sculpting mode where I can push, and right now I have a symmetry modifier. And so with this tool, it's like a lump of clay. I can push and pull and stretch. And so this is good for if you want a computer equivalent to what you would do by modeling with clay, you know, for making an expressive creature, for example. So that's sculpting in Blender. And then Blender has great tools for rendering and animation. So I don't often start in Blender, but I might design CAD in another tool and then go to Blender because I prefer Blender's tools for rendering. So here I'll make some assets in Blender, but I can also import these from another tool. Now I'm turning on a real-time renderer, and this comes from video game engines. So it's rendering in real time. Then I'm going to go into an environment that lets me pick materials. So I'm going to assign materials to these objects. And so that was walnut. Then I'm going to make a little movie. So I have a timeline. I'm going to have keyframes. And then I'll store keyframes, and now I'll run my movie. So I just gave material properties. I lit a scene. I'm animating it. It's making shadows. And then I can also do an even higher quality render just for a photorealistic image of what I made. There's a question about moving between apps. I'm going to talk about that when I get to formats. So Blender's a great tool for rendering animation, and I'll talk about in simulation. ZBrush is a popular commercial tool for the sculpting, like I showed you. Rhino is popular with designers. It's extended by Grasshopper, which is similar to Blender geometry nodes. Now let's come to FreeCAD. So I'm going to spend a while now in this class, and now let me come to this taxonomy. FreeCAD, Fusion, and SolidWorks are all good tool, and sorry, Onshape are all tools I recommend. I'm going to show you these examples in FreeCAD, but you can do them in all of them. These three are commercial. We have great collaborations with all three companies, and they give great support for Fab Labs and makers. So we have licenses. They have various forms of maker discounts and educational licenses. We have licenses arranged through the class. I'd say Fusion is best integrated in all the steps of design, simulation to see how it's going to perform, path planning to manufacture it, rendering to show it. All of those I'd say are best integrated in Fusion. SolidWorks is broadly used industrially. It's really good for industrial strength. I'd say among these tools, it can handle complex designs without keeling over. It has good tools for lifecycle management of like bill of materials and sending to factories. And SolidWorks runs locally. XDesign, but only in Windows. XDesign is essentially SolidWorks in the cloud. You can run it in a browser. And then Onshape was written by the original developer of SolidWorks. And if you're familiar with Google Docs, it's most similar to that. Onshape is only in the cloud, and from ground up, it's collaborative. So in a browser, you open a window and multiple people can be working. So all of them can do everything I'm going to describe. We have great relationships with all of them. They're slightly different in the ways I described. And then I'm going to give you these examples in FreeCAD. FreeCAD is freely available, cross-platform, and easily extended by the users because it's open. What I'm going to show you now in the FreeCAD examples, you can do the same things in any of these tools. So in FreeCAD, to start, it's based around workbenches. So beyond menus, each of these workbenches is a different mode you're in. So there's a workbench for sketching, there's a workbench for making parts, for drafting, for drawings. And then there are add-ons, and these add-ons let you add new workbenches. And so there's a very lively community building workbenches for things like robotics or laser cutting. I'm showing just some workbenches I like. And so the first thing to get used to is there isn't a single interface. you use the workbench. Each workbench sets up a whole bunch of menus and tools. Okay, so a first thing you have to do is snap. And once again, each of these concepts apply to all of these tools. So I have a grid turned on, and then I'm going to show you snapping. So right now I can move a part wherever I want. These are all different snaps. So one snap says I should only move in steps of the grid. So with that one turned on, right now I'm showing a snap that only moves horizontally or vertically. Here's a snap that says I have to move to grid points. That was a snap that says vertices touch. I showed you a snap that shows edges touch. All of these help you place parts by forcing alignment. So those are turning on and off various snaps. Coordinates are essential. So here's a cube. I can move it around. One of the key things is, let me pause here. So here's my cube. The cube has a properties panel. And in the properties panel, I can get in and I can numerically set the value of all these parameters. So I can edit it by clicking and dragging, or I can edit it by assigning numbers. And then a useful notion is containers. So you can put parts in a container, and the container can hold multiple parts. And then you can do snapping and alignment and all of those operations on the container. So here I have the cube in a container, and then I'm going to use a snap, and I'm going to move the origin of the cube. And that's going to set where, for example, when I rotate it, the center of rotation is. Let's see, there's a question about the licenses after the class. The licenses we're giving you are specific to the class. All three of these have free versions for education, and they have discounted versions for makers, but they are ultimately commercial tools. They're not free. The licenses we're giving you are for the class. I recommend using the licenses to learn them. They're good skills. And again, for example, they all have modestly priced maker versions, and professionally, it's good to know how to use them. But also, personally, I prefer to use the open source tools that aren't constrained by licenses. Okay, now there are a number of ways to go from 2D to sketching to 3D. So one is extrusion. So I'm in the sketching tool. I'm using here what's called a spline tool to make a curvy shape. Actually, there I was in the drafting tool. And now I'm going to extrude it, which stretches it from 2D to 3D. So that's one way to go from 2D to 3D. Another way is to do a revolution. So here I've made a shape. Now I'm going to spin it around, and now I made a bowl by spinning the shape to make a 3D object. Lofting is a powerful notion that comes from, for example, boat building. I'm going to make a shape. I'm going to change the plane I'm working in now. I'll make another shape in 2D. And now I'm going to loft between them. And I get a shape that continuously connects between them. And that had only two profiles. You can have many profiles. let's see, there's a question about, somebody comfort with just Blender and FreeCAD. I do recommend encountering the other tools. I occasionally, my lab, for example, at MIT uses all of these tools because each has different strengths and weaknesses. And so I recommend understanding what the differences are among them. Sweeping is yet another way to go from 2D to 3D. So what I'm going to do is I'm going to make a curve. Then I'm going to pick where I'm working and I'll make a shape. And then I'm going to pull my shape along the curve. And so I get that object. Then CSG is constructive solid geometry, and that's Booleans, but now in 3D. We saw that before in 2D. So here are two shapes. And now I'm going to take those two shapes and so I just did a subtraction. But the key thing is those two shapes still exist. So if I go to my tree on the left, you'll see the shapes are there. And I can go into the parameters and I can edit the cube or the torus. And then it goes through the steps I used to construct it. So there I subtracted. I can also add or intersect them. There I did it in the opposite order. Here what I'm showing is you can change the transparency that's useful to see inside the part you've made. And then there is just where they meet, their intersection. So CSG makes Booleans in 3D. Symmetry is an important concept. Often we have parts that have symmetry and you don't want to draw each part separately. So what I'll show here is, and I'm going to get to file formats in a minute. So I'm going to make a shape in the sketcher. So now I've extruded it. Now I'm going to mirror it. And I can control where I'm mirroring it. And I can control the angle of the mirror. And then I'll do a Boolean. And then I'll mirror it again. Now if I go back to the original sketch and I change the sketch, it propagates through all of those steps and I don't have to redo everything because of the symmetry. Then padding and pocketing is something you'll do a lot. Here I'm in a part design where I'll start with a shape. Then I'll pick a face. And I'm going to start working on that face. So now I'm sketching, but I'm sketching on a face of an object. Then I'm going to pad it. I'm going to do an extrusion, but I extruded it on the face. Now I'm going to pick another face. I'll start working on that face. And I just pick the face. I don't have to specify where I am. Now I'll make a sketch on that face. And then here I'm going to do the opposite. I'll pocket. I'm going to cut it out. Okay, so that's paths and pockets. Yeah, to Rico's question, there's different paradigms. Fusion maintains history of the steps you did. FreeCAD doesn't do history. What it does is it does a tree, and I'm going to show you more examples of that. It does a tree of the construction. It tells you logically all the steps, not the historical steps. I actually prefer that representation. So filleting and chamfering is taking sharp edges and make them smooth. And that's going to be important because sharp edges are where you get stress concentration and things fail, or fabrication processes fail. So filleting and chamfering takes edges and makes them faces or makes them smooth curves. And that's going to be important. Offsetting makes an object bigger or smaller. And so it inflates it or deflates it. And so, for example, that's useful for clearance. If you want a part to fit in a part, you might need to slightly shrink it by offsetting it. Then hierarchy is a key concept. So here I'm going to do in 3D what I did in 2D. So I'm going to take this object, then I'm cloning that object. This is similar to what I did in 2D. I'm going to place them. I'll use that to make a cutout. I'll place this object, make a cutout, and then similar to what I did in 2D, if I edit that first object, it'll propagate through my design. Here, I'm going to show the connection between constraints in 2D and 3D. So this is a very powerful thing. So I just did a Boolean. Now I'm going to sketch on that face. What I just did was I just imported an edge into my sketch. Now here's a circle, and I'm going to say I want that to be tangent. I want them touching. Then I'm going to use my circle to drill in. And now I'm going to do something really non-trivial. I'm going to change the sphere, recalculate. And what just happened was the sphere went to the Boolean went to the sketch went to the tangency, and then the tangency went to the cutout. And so that's using 2D sketches as part of the construction of a 3D design. Let's see, here I'm showing the opposite. What I'm going to do is I can project a 3D object down to 2D. So here are 2D projections of the 3D object, for example, for cutting it out. And I can also make sections. So I'm going to make a 2D section of the 3D object to cut it out. Let's see. Question in the chat. Fusion is paid, is commercial. FreeCAD is freely available. Assemblies are a really important concept. So I'm going to, and this has gotten much better in FreeCAD, I'm going to make an assembly, which is like sort of like constraints, but fully in 3D. So I have two objects in my assembly. And then I can describe 3D relationships. So right now, if I move that, nothing happens. but I can take my two objects. Then I can say I want them concentric, I want them aligned, I want them touching, all the things we were doing in 2D. So now, because I've made that, if I move this, the other part follows because they're connected into an assembly. Because of all these solving tools, you can make things and not even know the size and shape. So an important thing you can do is make measurements on your design. So here I'm picking some points, and then it'll give me a readout of the coordinates. If you don't specify the dimensions after a set of operations, the measurement tools are handy for that. And here I'm adding a dimension to the drawing. Folding and unfolding historically is called sheet metal, although it's much more than sheet metal. What I'm going to do here is I'm going to go into a folding tool. Then I'm going to make folds on the faces. Here I'm making, in this case, I'm making a little box. And then a key thing it can do is it can then unfold it. So I can cut it out in 2D and then fold it into 3D. Okay, now we come to the most important one. So number one important skill from today was constraints. This is the second most important skill. This is parametric design. So let's say you design an airplane and the fasteners aren't strong enough and you need to change every fastener in your design. It's not feasible to click and drag on every one. The way you do it is what I'm going to show you now. And I like how FreeCAD implements this. So I'm going to make a design. And here are two parts of my design. Now I'm going to add a spreadsheet. So the spreadsheet lets me enter variables and formulas. So I'm going to name a variable, radius. I'm going to give it a value. And I'm going to make it a math variable. Here I'm going to rearrange my windows. Now, remember down here, each object has data. I can go into the data, and instead of typing a number, I can put in a variable from the spreadsheet or a math formula. So here I'm going to tell it, use a formula, use the spreadsheet, and take my variable. And I'll do that for both of those spheres. So now if I edit that one number in the spreadsheet, it goes through the design, but the spheres don't move. So let's take their position. And here I'm entering 2 times the radius. Or let's see. Yeah. So now what I'm going to do is if I edit that number, the spheres get bigger and one of the spheres moves relative to a number, the other one. This is one of the main things for you to learn this week if you haven't done it. So when you make your cardboard cutout, you have a formula for the thickness of the cardboard, and then you use that to make your slots, and the spreadsheet variable gets used throughout your design. And I'm going to show you interesting examples of that as we project. So that's parametric design. And yet next week in computer cutting, I'll show you more examples of that. Then after parametric design, these are macros, which are programs. FreeCAD lets you write in Python, which is a lovely language. And so I'm going to show you some macros. And so I'm going to run this macro, and that made a gear for me. And gear design, we'll see later in mechanisms, is surprisingly subtle. And then, so here's the little program, and there's a whole community posting these. Eventually you can write them, but you can get lots of these. Here's another macro I'll run, and this is a good example. I'll run this one, and it just made a honeycomb for me. And so it would be a lot of clicking and dragging to make that honeycomb, but here you can run this macro and it generates it for you. So let's see. Then this is a workbench for technical drawings. And so you can take your 3D design, you can turn it into a line drawing. And in particular, there's a lot of things you can do because it understands the 3D. So we can pick different views. So here I'm picking different directions to view it, and you can do cutouts in the drawing. So for documenting your work, for describing it, that's the drawing tool. FreeCAD has tools for rendering and animation, but they're very rudimentary. They're weaker than the other tools. The FreeCAD renderer, it doesn't understand photorealistic real-time rendering like Blender does. You can assign basic material properties to it, and then you can call out to, I'll jump ahead, to an external renderer, and then run it and get a render. But it's not nearly as well integrated as the other tools. And the animation is pretty rudimentary. So those, all of those skills you need to learn to be ready for what's coming. So sketching with constraints, going from 2D to 3D, doing CSG in 3D, making assemblies, and most importantly, out of all of this is the parametric design. Hierarchical design is a part gets instantiated many times, so you change one part and it appears everywhere. Parametric design is rather than just clicking and dragging, you enter formulas and they propagate through your design. You can do that with all of these tools. It's essential to get started. There's a question about gears. Yeah, FreeCAD has good gear generation. So let's see, for time, let me show OpenSCAD and Open then JSCAD. This is based purely on a hardware description language. So this is a version running in a browser where here, instead of clicking and dragging, you write a geometry program and it produces your design. And that can be preferable for things you think about algorithmically. Matt Keeter, who I mentioned, wrote a really interesting tool that's very different based on functional representations. So an FREP looks like, if you take, say, x squared plus y squared, if you take that formula and say less than 3, inside a circle, it's less than 3. Outside a circle, it's greater than 3, and it's 3 on the boundary. And so that formula actually describes the interior of an object. So in this tool, on the right, you're making what's called a data flow graph. And then on the left, you're making a functional representation. And so far, this doesn't look any different than what we've already seen. But in a little bit, I'll show you how the FREP is very different. So right now we're making a graph of construction.
Hey, Neil,
Yep.
where are we with where is this now? I
Um,
tried to fool around with it about a couple months ago, and it seemed like it was the development had stopped.
I'll talk about that in a second. So
Perfect. Thank you.
yeah, the so what I'm showing now is this is how you make it parametric. You can introduce variable nodes, and each node is a little program. So the variable nodes can use those. And so far, that's still interesting, but now comes the fun stuff. So now what I'm going to do is I'm going to add a repulsion node, and this has no analog in other environments. This is going to completely sort of smush the whole shape. And then what I'm going to do is I'm going to add an interpolation node. And so this can give me a shape in between other shapes. So now I can continuously interpolate between this shape and that shape. And you just can't do that with other kinds of CAD tools. So the answer to that is Matt created that. It turned into antimony. It then turned into Lib 5, and Lib 5 is the current library version. And I don't think Matt has a current GUI for it. Right now he has it in this programming language, but Lib 5 is the most recent version he's been doing of that. So he continues to develop. If you have issues, send me a note and I'll introduce Matt.
Thank you.
And yeah, and that was the base of Entopology. Finally, on this, GrabCAD is a handy site for sharing designs, and it lets you embed let's see, I'll fix that link. It lets you embed a 3D viewer into your site. Okay, a bunch of things before we finish. So anytime you export from any of these tools into another tool, something goes wrong. Yeah, once again, Anemone, Lib 5 is the current tool that Matt's working on. Anytime you export and import into another tool, something tends to go wrong. Stay away from DXF if you can. DXF is an Autodesk file format. It's not an interchange format. It's a mess. Use it only if there's no alternative. STL describes object as triangles. You lose all the design information, but it's common in 3D printing. OBJ is an more recent Autodesk file format that contains more information that's pretty good for interchange. EGIS was a early version to standardize interchange. It's not well supported. STEP is now pretty good. So if you export STEP from one of these tools and import it in another tool, it does a pretty good job of transferring. So STEP I recommend. And then these have grown up around graphics. Quickly, McMaster-Carr is a vendor of parts, and all of their parts come with CAD models, which is really handy if you're looking for CAD models. FreeCAD has a nice library. Let's see. FreeCAD has a nice library of models. Then the video game engines, Unreal and Unity are commercial but have free versions. Godot is open. Let's see, Ahmed is asking about DXF. SVG, yeah, I should mention SVG. SVG is good for 2D. I was talking specifically about 3D interchange formats. SVG is great for 2D, but not for 3D. The game engines all let you build assets. and then do real-time rendering and scripting and interacting. So you could do the whole class in them. These are maturing tools that let you sculpt with virtual reality or augmented reality. So these are popular tools where using, oh, I think, oh, that's funny. Tilt brush, I'll have to fix that link. These all let you either with an augmented reality or with virtual reality sculpt by working in a 3D space, not a 2D space. Okay, now I'm going to talk about simulation. So Blender has a physics engine that understands all of this physics, not guaranteed to be accurate for fundamental physics simulation. I wouldn't build an airplane based on it, but it lets you do things like this. So I'm going to make a chain. So I've just made a chain. Then I'm going to turn on physics. So right now there's just gravity, so it falls. But I'm going to anchor that one loop. Now I drop it and the chain swings. And now I'll jiggle it around. And so if you want to model your final project, you don't have to painfully animate each of those steps. You can actually just build physics into it and then run the physics model. And so it's surprisingly powerful. It understands fabric, squishy things, fluid things, particles, surprisingly powerful for simulation. These are all, let's see, this is a class I teach on mathematical modeling. These are more powerful modeling tools, but physics is a good starting place for physical simulation. Two final topics. You're going to be making movies to document your work. Audacity is freely available cross-platform audio editing. So you can use that to build soundtracks. Once again, stay away from GIF other than for a few frames. You're going to need a video editor. Again, because I prefer freely available cross-platform tools, all of my videos go through KDN Live. Maybe even 5 years ago, these tools were rudimentary and unreliable. They're very polished. They're very mature. So all of these let you take images, video, soundtracks, composite, transition, label, do all the things you see in movies. So there's a wide range. So these are commercial tools. These are freely available. There's a wide range of them. Then this is essential. So FFmpeg is like the 2D, the image tools we showed you, but for video. These are a few other ones. Handbrake is one with a GUI. What these let you do is convert any video to any format. These are open players to play all the video formats. Now, here comes an important, a very important thing for, let's see, your sites. I'm making notes of little edits. HTML5 is what I mentioned that's where the web developed video and audio, among other extensions. Crucially, there's a limited set of video types that you can play on the web without plugins. And so a media container is the type of file, and then within it, the codec is how you encode it. And so there's a limited set, and among them, I recommend MP4 with H.264. So MP4 used to be proprietary. Now it's not constrained. And then H.264 is good quality encoding. I'll make a note. It should be on the order of a few megabytes per minute for web resolution. H.265 is a more recent codec that's even better than H.264, but stay away from it because not all operating systems and not all browsers know how to play H.265. And so you'll run into not being able to play it. For example, I use just standard cross-platform browser tools. And so make sure you stick with H.264 for compatibility. So here's a series of commands. If you don't like seeing those commands, Handbrake is a nice tool that lets you do it with a GUI. But if we come back to here, this takes your input video. It specifies the frame size. So this is 1080p. And then here you can either specify the quality or you can specify the bit rate. Here I pick the audio coding, and this is MP3. And then this will take your video, whatever format it is, and output it. This will make a video without sound. This will let you crop the video. This will let you trim it. This will let you separately mix audio and video. This lets you crop, pan, composite. This is a really great thing instead of GIF. If you have a series of images, this lets you make a movie out of the images. So you need to be comfortable with this to take the video you record and compress it down to a few megabytes per minute. Then these are some tools. This is what I use to record the screen videos I showed you. You'll need to do that. This is a really handy tool. This turns your computer into a production studio. So it lets you take multiple sources in, manage them, and send them out to multiple sources out. Okay, last is AI. This is from a recitation on AI. In 2D, there's lots of options to make images. You're likely no doubt familiar. So Midjourney, DALL-E, Stable Diffusion, they make nice pictures that often are slightly creepy, and if you look carefully, are slightly wrong. Then for 3D, right now, this is rapidly unfolding. You can ask a 3D tool to do CAD for you. This is a nice paper written by a group of colleagues. And what they look at is, does large language models help you do CAD? And one of the main points in this paper is they understand how to generate CAD, but they don't understand physics. And so they can make a wide range of mistakes that are unphysical. So these are all projects aiming. The problem is the large language models don't have a real representation of geometry. They're just words. These are all projects that are currently aiming to bring geometry engines into AI environments. Those are all very much works in progress. There's no one of these I would recommend as being ready to use. They're all rapidly unfolding. And once again, we'll schedule, let's see, in the schedule, the next recitation is getting you ready for programming. The one after that, we'll talk about all of these AI tools. And let's see, I didn't link this one. I'll add this link. These are unfolding, on a weekly basis. So this is a version of Words to CAD. So stepping back now, there may be 10 different design tools I use. This is like a drafting bench. At your drafting workbench, you have a pen and a ruler and a compass. In the same way, no one tool will cover all of this. At any one time, I use maybe 10. Sorry, let me go back here. So what I want you to do is model a possible final project. So do a raster image, do a vector image, show it in 2D, show it in 3D, make a photorealistic rendering, make a movie, if you can actually simulate it working. You're going to produce images and videos, compress them using the tools I covered, and then post a description with the design files on the class page. And Rico's asking the whole project, not a part of it. Rico, it's really open. The goal of this week is to get you thinking about a project and to get you going with the CAD tools. It's fine however you want to interpret it. We're not going to carefully evaluate what you model. We want to see that you model. And so I walked through a range of commercial and open source tools. Every one of these has people who love them and people who hate them. And so asking which one to use is like asking who you should date. Dating is a very personal preference. We can't tell you who to date, and we can't tell you which tool to use, but we can tell you the difference in the tools. Benedict is asking about, so where is it? This week, we'll talk about electronics design. And in that week, I'm going to introduce some new electronics tools. One of them, though, is built into Fusion. So one of the strengths of Fusion is it also builds in a nice version of electronics design, but we'll also cover freely available open electronics design tools. So no group assignment this week. In the coming weeks, there'll be lots of group assignments. And the main thing you should do is try as many tools as possible and see what works for you, and try to work through this whole hierarchy. And as you manage your time, go back to here, remember next week, you're going to be designing a parametric construction kit for press fit assembly. And here in the remaining minutes, I'm going to go through this example more slowly. Here's my example of a construction kit. So here's a detailed constrained design. Here's the parametric part, and then I can edit this and it updates my whole design. You need to be ready to do that next week. So focus in on constraints and parametric as the most important skills to learn from this week. Okay. No recitation, but the Saturday team is ready at 10 o'clock, and they specialize in you showing up and screaming and panicking and saying, I'm overwhelmed and I don't even know what to do, and help. And they're really good at bringing you down from that and getting you going. They're also good at, I got started and everything broke. So they're a great resource to help you with that. And final suggestion, remember, keep a tracking page on your final project. Remember, document as you work. You'll run out of time as you end. And remember, supply side time, make a schedule for the week in advance. Don't hope that you finish on time. Okay, so we're done the not so fun part of just learning Git and getting started on the web. This is a bit more fun, learning design tools. And then, let's see, Jacob is asking, the tracking page on the final project isn't really a requirement. It's, when you present your final project, we want to see the development. And so it's really a tool for you to force you to on a weekly basis, be updating your work, and it's a way for us to follow along, and then it's a way for people who follow you to learn what you did on it. And so other than its existence, it's just really, think of it as a notebook to help you work. And so after this, we're done just with software, and next week we get in the lab and we start making things. So good luck and happy designing. And this is a creative week. I look forward to seeing what you come up with next week. Bye-bye.
Cześć.
Bye.
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 Adiós, amigos.
Audio.
Until next time. Yes.
Tchauzinho.
Bye-bye. Good night.
Good night.
Good night.